Professor Bumbleweed here. Ever notice your phone knows where you stand, even when you feel lost? This quick video explains how GPS pulls that off. Satellites, timing, and math. Served entertainingly and usefully with just enough sarcasm to stay awake. GPS starts with satellites doing one job, shouting the current time, constantly. They also broadcast where they are in orbit. Your receiver collects several of these space beeps and uses them as reference points. Yes, it's glorified timing. First step, your device identifies satellites and locks onto their codes. It pulls timing and orbit data from the broadcast message. After that, it focuses on one thing, how late each signal arrives. Those microscopic delays become the entire location story. Here's the not-so-mystical trick. Signal travel time. Satellite sends a timestamp. Your receiver measures arrival time. Travel time times light speed gives distance, called a pseudo-range. If your clock drifts, that distance lies. GPS corrects it later. Think of it as distance bubbles. One satellite distance gives a giant sphere. 2 spheres intersect along a curve. 3 intersections shrink to a couple of points. Then Earth's surface and extra checks pick the sensible one, because nobody lives deep in space. 3 satellites sound enough, but your phone clock isn't perfectly synced. That timing offset acts like an extra unknown distance, so GPS uses a 4th satellite. It solves latitude, longitude, altitude, and your clock error together. Annoying, yet brilliant. GPS doesn't guess in street names. It outputs coordinates in an Earth-centered reference frame, tied to a standard Earth model. That's why it works globally. Your map app translates that coordinate into a friendly dot on roads because humans love pictures. Real signals travel through atmosphere, and the atmosphere slows them slightly. In cities, signals also bounce off buildings, so the receiver gets delayed echoes. GPS measures time, so extra delay looks like extra distance. Congratulations, physics pranks you. Augmentation systems broadcast correction data that accounts for satellite clock and orbit errors and some atmosphere effects. Receivers fold that data into their range calculations, so the solution shifts closer to reality. Not perfect, just less embarrassing when navigating. In the real world, phones cheat in a good way. They use network assistance to speed up satellite acquisition and improve time knowledge. They also track multiple GNSS constellations, so even with blocked sky, enough satellites remain to compute a decent position. Your phone rarely trusts GPS alone. It blends satellite fixes with motion sensors, plus known constraints like roads or building outlines. That fusion smooths jitter and bridges short dropouts. So when GPS wobbles, your phone pretends everything stays fine. Bold strategy. If this felt both fun and useful, drop a like. It tells us which explainers hit the mark, and it helps prioritize future topics. Either way, thanks for spending a few minutes with satellites, timing, and suspiciously polite math. Want another topic covered? Drop it in the comments. Specific beats vague. Tell me what confuses you most. Otherwise, I remain the silent mascot of missed potential while the animators wait for direction. Give a prompt, and we keep the explainers rolling. See you soon!